We'll get going. Welcome, everybody. I'm Doug Nowacek at Duke University and would like to welcome you to the Ocean Quieting Workshop Series hosted by the Global Alliance for Managing Ocean Noise, affectionately known as Game On. Game On is an international partnership of proactive and action-minded scientists, managers, policymakers, and industry representatives fostering inclusive dialogues to fuel creative, workable solutions that will transform ocean noise management. Game On is developing responsible, modern, integrated, and informed solutions for managing anthropogenic noise by proactively identifying emerging concerns and solutions, mapping existing and emerging knowledge on ocean noise, technology, and policy, and creating space for inclusive dialogues and networks to collaboratively solve ocean noise issues globally. We thank you for joining us for Workshop 2, Practical Approaches for Reducing Ocean Noise Associated with Seismic Exploration, where we hope to foster a productive setting for stakeholders from multiple sectors to debate, break down barriers, and ultimately develop data-informed and technologically advanced solutions to the challenge of ocean noise. The focal topics of this workshop will include operational and engineering solutions from engineering to regulation, and will culminate by identifying and proposing opportunities for actionable next steps. Again, Game On is focused on finding and pursuing action items that will help us to quiet the oceans. I will now hand it off to my colleague, Brandon Southall, founder and director of Southall Environmental Associates and Game On co-chair, to tell you a bit more about the structure of today's workshop. And again, thanks for joining.
Thanks, Doug. I appreciate it. I appreciate people joining and their interest and involvement in this. The session today will be 2 hours. We'll really have a strict time. We'll try to meet so we have plenty of time for discussion and engagement. This will include the speakers' presentations in the first hour and then a panel discussion in the second hour. As attendees, the cameras and microphones are not functional, but we have questions and comments that we can receive in the Q&A, which we'll be monitoring throughout, and will include feedback and input and comments in the reporting out on this. So we want people to be involved, but that's how you can engage. We also encourage you to go to the Game On website, link to the registration, so you can see other topics related to the project, who's involved, descriptions of future workshop sessions, this being part of a series. Today's session will also be recorded and posted to the website later this week. So I'm going to introduce, we have 3 speakers. I'm going to introduce all of them at the beginning, and then we'll just move through them. I appreciate all of them. They're highly qualified people to speak to this topic. First is Mike Jenkerson. Mike retired from ExxonMobil in 2021 after 43 years in the oil industry. First with Geophysical Services International, then Mobil, and finally with ExxonMobil. During his tenure, he managed geophysical operations research program that investigated alternate seismic sources. For the last 15 years, he's been part of a small team within ExxonMobil that studied the impact of sound from exploration production operations on the environment, made recommendations to the business units on how to reduce sound from company operations. Mike has been the research category chair for Category 1, sound source characterization and propagation for the IOGP Sound and Marine Life Joint Industry Program. And Mike's been involved in marine vibroseis research since 1992. Following Mike, you'll hear from Shuki Ronen, who has a Bachelor of Science in Physics and Geology from the Hebrew University in Jerusalem and a PhD in geophysics from Stanford. He worked as a geophysicist, manager, and educator in Saxby Computer, Colorado School of Mines, the Geophysical Institute of Israel, Schlumberger, Veritas, DGC, Chevron, Seabird Exploration, CGG, Seabed Geosolutions, Dolphin Geophysical, Totem Geosolutions, Low Impact Seismic Sources, and today serves as an adjunct professor of geophysics at Stanford and chief geophysicist marine at Sercel. And last but not least is Jill Lewandowski, who's been pretty involved with us in Game On since the start. She'll share the regulator's perspective with her experience as the chief of the Division of Environmental Assessment within the Office of Environmental Programs and director of BOEM's Center for Marine Acoustics. Collectively, Jill leads a team of experts in providing national oversight of BOEM's compliance with environmental laws and driving bureau-wide improvements to understanding, assessing, and communicating environmental risks. With close to 30 years of professional experience, Jill has worked as a protected species biologist for BOEM, NOAA, and the National Wildlife Foundation, and remains a key expert internationally on marine sound issues. Jill holds a BA in biology from the University of Virginia and a master's and PhD in environmental science and policy from George Mason University. So thank you so much, Mike, Shuki, and Jill, for sharing your wisdom and insights with us today. And I'll pass it over now to Mike to kick off our conversations, which we have scheduled as 15 minutes for each of the three presenters.
So I need to share the screen, right? Just a second. I'm keep on getting messages. Okay, so I was asked to give an overview presentation. Well, I believe I'm supposed to stop my video, right? But
keep your video on, Mike, you're good.
Keep it on, okay. I was asked to give an overview presentation on the operational engineering solutions for seismic surveys. I've collected them because of the diverse solutions. I've collected them into three broad buckets. And I understand that some of them could go into more than one bucket, but the three buckets are operational methods, which are really methods where standard equipment is used, engineering modifications where some, at least limited engineering could be required, and new technologies, which are basically totally novel technologies. And then I'll just have a quick review at the end. The operational methods are temporal and aerial closures and reducing the output from an airgun array. The engineering modifications are modifications to the airgun design, clustering of elements to tilt the output to lower frequencies, desynchronization of airgun firing times, and the use of external attenuators, such as bubble curtains or airgun mufflers. The new technologies include marine vibrators, which there are 3 or 4 now designs under development, and airgun and vibratory sources, which are designed to generate very low frequencies. Okay, let's start with temporal avoidance. The temporal avoidance is a limitation of the times when seismic activities can be conducted. Then it's normally related to critical life cycle stages for animals in the area, and will generally result in a total reduction in the acoustic output from seismic during these closure periods. The operational cost would be low unless there is a significant overlap between the temporal closure window and optimal operational times. And a good example of that is Sakhalin, where there is a very limited window, both for the mammals to be there and for any operation to be conducted. Aerial avoidance is a designation of areas where seismic activities cannot be conducted. Generally, this is designed to protect a location where sensitive marine fauna life cycle stages take place. And it results in a significant reduction in the acoustic output from seismic in the closure area. The operational impact can extend significantly beyond the closure area, dependent on the acoustic levels that are allowed to impact the actual regulated area. And in some cases, this can severely hamper or stop development. The third operational method is to reduce the acoustic output of the airgun array. Under normal circumstances, the shot-generated noise will be the limiting factor for the signal to noise. So operators try to maintain a source level slightly larger than that needed for imaging in the area. The high frequency output from air guns is often a byproduct of trying to generate more low frequency energy. and also some of the original drivers, the sales drivers for the specifications for airguns. Advances in receiver technology, whether it's solid streamers, 4-component streamers, and 3-component MEMS OBN sensors, can improve the signal to noise of the recorded data, especially at low frequencies, and often enable the use of smaller output sources. Very long offset surveys could still require large array sizes, although there are other solutions to that specific task. Reducing the output from an airgun array can reduce the levels across the whole spectrum, depending on how it's accomplished, and it should have a minimal operational cost impact. The next engineering modification is to modify the airgun design to reduce the bandwidth. And Teledyne Bolt with eSource and Sercel with Blue Pulse have developed modifications to airgun designs that suppress the frequency content outside the main seismic bandwidth. Modifications to the airgun port shape, shuttle velocity, and reduction in acceleration distance all slow the release of air, reducing the spectral content above 100 Hertz while maintaining most of the energy below 100 Hertz, and thus the seismic image quality. It has an additional benefit in that it lessens the likelihood of cavitation. The updated airgun designs are compatible with existing peripherals. Because slowing the air release reduces the peak amplitude and the rise time of the output signal, it should also decrease the SEL, tilting the spectral content of the signal to lower frequencies. There should be no operational impact of the use of these types of sources. Standard airguns, Bolt and Sercel, can be updated, although that can be a significant capital cost. But it's also not having to replace all of the ancillary peripherals reduce the cost of change. Another option is to cluster the elements in the array to modify the spectrum. A hypercluster of standard airguns can be used to create a larger effective bubble volume. Shearwater's Harmony as an example. The airguns are not close enough to coalesce, but are close enough for the bubble interaction to occur through the pressure field. And this leads to a bubble frequency that largely equals that associated with the combined volume of the guns that are being clustered. And the airgun bubbles act as one large bubble oscillating with a period of a bubble with a total volume. This hypercluster technique allows a generation of lower frequency energy and probably, from a practical perspective, reduces the high frequency components as there are fewer additional bubble frequencies, and because you're clustering all the guns in the array, and the peak amplitude and SEL will probably be reduced for that reason. It should have a minimal operational impact and cost as current equipment is used for this type of source. Another example of different type of design is ION's Gemini. This is a high volume cluster source which can have, which operates at pressures of about 2000 PSI and has larger volume chambers, which can be about 4,000 cubic inches for conventional streamer work and about 8,000 cubic inches for sparse surveys, low frequency. It's an isotropic point source with a stable low frequency bubble oscillation. And it generates more energy below 7 Hertz and less energy above 70 Hertz. Between 7 and 70 Hertz, it has a fairly flat spectrum, but it is lower than a standard airgun array. As I said, the source can be used either as across a full seismic band, in which case a different design, a different chamber size is used, or for a sparse grid to get low frequencies. And it enhances the low frequencies to 2 to 7 Hertz, and as I said before, keeps the mid-band flat and lower than a standard airgun array, and reduces frequencies above 70 Hertz. And again, the peak amplitude and SEL should be reduced. Operationally, there shouldn't be a lot of impact, but there will be a cost in switching to the different chamber design. Another option is to desynchronize airgun activation. Standard seismic arrays activate all the airguns simultaneously. These new methods stagger the firing times of the elements within the airgun array to alter the output from the array, or the effect is to alter the output from the array. If the timing stagger is small, just a few milliseconds, the high frequency output can be reduced without affecting the low frequency spectrum. In effect, it's tilting the array spectrum. The synchronization from the scattering delays can be chosen to conform to a specific statistical distribution. The level of desynchronization determines the amount of out-of-band reduction. If you, for instance, choose an 8 millisecond desynchronization, you'll get an average of about 12 or 13 dB at frequencies above 118 hertz, with a reduction in the peak pressure in SEL and an obvious reduction in the bandwidth. There should be minimal cost or operational impact to these to this technique if the airgun controller can operate with these timing delays. A larger scattering the timing of the airgun activation in the range of seconds for e-seismic or popcorn triggers the airguns in a near continuous fashion with short randomized time intervals to generate a continuous wave field. The emitted signals approach the properties of white noise in many cases. The peak's amplitude is decreased significantly, about 20 dB. The bandwidth is similar, and a small SEL reduction should be expected with an increased duty cycle depending on the exact technique that's being used. And so all of these parameters depend partially on how you're doing the actual desynchronization. There should be minimal cost or operational impact again. The last set of engineering modifications are curtains or mufflers. Small bubble curtains around airgun ports can generate a stable screen to reduce sound propagating through the bubble curtain. The amount of attenuation depends on the thickness of the curtain, the size of the bubbles, and the frequency of the propagating sound. For a fixed source, such as a VSP, a bubble curtain could be effective in shallow water. Because it's fixed, you can sort of use a bubble curtain very similar to the way we do with pile driving. A small reduction can be seen at frequencies above 50 hertz, small reductions in peak amplitude and SEL, but really, except for a fixed source, the technology is not very viable. The cost and operational complexity make it just impractical. Airgun mufflers use acoustically absorbent material suspended on radially oriented plates around a conventional airgun array. There are modest reductions in output at frequencies above 700 hertz, with slight reductions in peak and SEL, but the cost is significant. The technology is operationally impractical as the material degrades after very few shots. Marine vibroseis. This is a new technology now. Energy at frequencies lower than 100 hertz is required for effective seismic imaging. For an environmental perspective, the optimum seismic source is a source that generates energy only at the frequencies and source levels required for imaging in the area. This of course can vary from area to area. Marine vibroseis techniques allow the output from the source to be highly controlled in the output level, bandwidth, and phase. The non-impulsive nature of the marine vibrator output and the lower peak pressures are expected to have lower impact on marine mammals, fish, and turtles, and the area of insonification should be significantly reduced. Additionally, amplitude and phase control capability of the source allows more effective removal of residual noise. Separation of simultaneous and interfering sources are easier, and it's been suggested that transverse horizontal gradient sources can be used to enable more effective reconstruction of the wavefield between source lines, allowing less shots to be acquired and faster acquisition. The peak amplitude for these types of sources is greater than 24 dB down. The bandwidth is limited and very controllable. The SEL is reduced and the duty cycle will increase from 50 to 90%. The initial cost will be significant as there are no full arrays available. Once systems are operational, the differential cost should be small. The effective amplitude and phase control could significantly reduce acquisition time and cost and increase operational efficiency. Very low frequency sources. These low frequency sources are used primarily to improve the low frequency content of the data by an octave or two, generally in the 1 to 5 hertz range, for FWI and subbasalt imaging. The signal to noise at these frequencies is significantly improved with these types of sources, over 15 dB. These sources are generally used in addition to conventional bandwidth sources for imaging. One of them is a Sercel TPS, which has lower operating pressures, about 600 to 1,000 psi, and larger volume chambers, 4,800 to 2,800 cubic inches. It's got a redesigned head with an air-filled mid-chamber, zero acceleration distance, smooth, almost 360-degree ports, and modified shuttle shape. It reduces a large volume of air over a controlled time, generating a long rise time and low-frequency bubble oscillations with less bubble turbulence. As long as you're using it for the low-frequency parts, then it doesn't. It generates basically more energy in the very lows, less energy above about 10 hertz, and significantly less energy above 50 hertz. And so it depends what the goal of the survey is, but if it's for low-frequency imaging, it doesn't require a lot of high-frequency energy. The vibratory low-frequency sources, such as WolfSpar, they're developed to improve the very low frequency content. They use large volume displacements to generate lower frequencies. The spectral output is focused in narrow frequency bands in the less than 10 hertz. And for a full seismic band, a standard seismic array, whether it be any of these different types being discussed with airguns or vibrators, must be used. So in summary, the presentation has shown that a number of operational and/or engineering solutions are available to reduce or modify the acoustic output from a seismic array. The optimum solution is largely dependent on the specific environmental issues that need to be solved. Different techniques can reduce the different characteristics of the sound, the peak, bandwidth, SEL, or duty cycle. The characteristics of the sound output from seismic operations can be significantly modified by new technologies and methodologies, which can more effectively target the output energy to that required for seismic imaging. Some of the new technologies can have significant cost and engineering hurdles to overcome, but can have significant impact if operationally viable. One interesting anecdote is that if you look at airgun development over time, a lot of the things we're trying to do now to reduce the output from airguns were things which were in the beginning worked towards to try and change the output from airguns to get higher peaks, higher primary to bubbles, all of these things. And so, experience has taught us that it is possible to generate lower outputs using airguns. Thank you.
Thank you so much, Mike. That's excellent, broad perspective and really detailed insight. So very appreciated. Let's move right on to Shuki. Maybe you can get your presentation shared and get rolling, Shuki.
I need to stop, right?
Yes.
There we are.
Okay, thank you, Mike. Fantastic overview. Let me share, and I hope you're seeing my presentation now. Yep. So I was asked to give 15 minutes on specific engineering solutions, and I would list them. Mike actually covered all of them really well, and I will choose one to expand on. And although Brandon has presented me with all my background, I'd like to just, for the proper disclosure, I'm working for an equipment manufacturer, 50% for Sercel, and I'm also an adjunct professor at Stanford University. Okay, so specific engineering solutions, and this is a bit of a repeat of what Mike presented, and it's 1, 2, 3 in the order of escalating cost, as Mike said. Starting from modified airguns, eSource and Blue Pulse, they're all trademarks, and you can notice that nobody's using the word gun anymore. And they increase, as Mike said, the rise time of the main peak, so they reduce the high frequency content, and still providing what's needed for geophysics with a reduced impact on the environment. And this is relatively low cost. Blue Pulse is sold as a conversion kit. So you just change the shuttle and you take a G source and you make it a Blue Pulse. The second in escalating cost, the second group, which right now there is only one, is a completely redesigned. It is still a pneumatic source, so most people will refer to it as an airgun. So it is still an airgun, but it's completely redesigned and taken some of the features in airgun that made it just like dynamite, because this is what the market expected in the 1960s, were taken out of the airgun and redesigned into the TPS. So it does, like Blue Pulse and eSource, it increases the rise time, reduces high frequency content, but it also eliminates or at least reduces very much cavitation. And so the very high frequencies, and I'm talking about frequencies above 1500 hertz. The third group is marine vibroseis. Cavitation, never had it, never will. It's a really good mid-frequency source, 5 to 100 hertz. They can go down below 5 hertz, Wolfspar, for example, but it has to be really big and heavy. And right now it's considered impractical. Even BP themselves are not using Wolfspar. So out of all of these trademarks in front of us, I chose to expand on the tuned pulse source. So let's go to the tuned pulse source. This is a picture taken from a GoPro just after a shot has been triggered. And you can see the bubble, a really nice bubble on the left, on the right. The TPS itself is this torpedo shape. There is a head, the head is inside the bubble. Just the scale is, it's about 2 meter bubble radius. This one is a 26,000 cubic inch chamber, and it's a fairly large bubble. It is a pneumatic source, so most people will call it air gun, but to separate it from conventional or standard air guns, as Mike said, lower pressure, factor 2 to 4 less than air guns. It has a larger range of volumes. This one in the picture is 26,000 cubic inch, compared to whole arrays are usually 5 to 10,000 cubic inch. And it has a substantially different design. Two advantages. One is the geophysical motivation, which is low frequency, coming from the ability to put large chambers on it. And the other motivation is environmental, because we avoid cavitation and there is less high frequency and ultra high frequency output. So just to quickly cover the geophysical motivation, this is a figure that actually was prepared by one of the customers of Sercel, and it shows data from an ocean bottom node. There were two shot lines which were collocated, TPS on the left and air guns on the right. So we have time going down and we have offset, increasing offset going from right to left. And this is signal below 4 hertz high cut. So the data processors are interested in the low frequencies because it allows them to build velocity models. So they're looking at what signal do we have below 4 hertz. And you can see this 5,600 meters per second refraction and the 7,700 meters per second reflection. They're coming from the lower crust. They're coming well below the salt in this case. And they need it, they love it. That's why they want sources like TPS, like Gemini, and like Harmony. But then there is another motivation which for TPS, which is the lower environmental impact. Some of the trademarks that I will now relist, they have either one motivation or the other. So Gemini and Harmony, they only have the low frequency motivation, the geophysical, because they use standard airgun heads. They don't have new heads. So the same heads which generate cavitation and generate high frequencies, they're just fewer of them, because instead of having large arrays, they're basically clusters of say 2 to 6 heads, as opposed to arrays of up to 30 heads. Now, eSource and Blue Pulse, they have new heads, they have modified heads, So they do have the environmental motivation of less high frequency, but they don't have the other motivation which TPS and Gemini and Harmony have, which is low frequency content. So I think both Mike and I were talking about heads and chambers, so I'd like to show some pictures. First of all, this is a TPS being deployed in the Gulf of Mexico. This is, by the way, a float. It's bigger than the TPS. So here is the TPS, and this is on the left, it's the head. You can see the ports. And on the right, you can see this is the chamber. And in this case, this is a 26,000 cubic inch chamber. Airguns also have heads and chambers. This is pictures that I took a few years ago in a quarry in New Hampshire, where we were testing TPS and airgun side by side, shooting into the same near-field hydrophones. So airguns have heads. This is the head of the airgun. This is the head of the TPS. And then this is a 280 cubic inch chamber of an airgun. And this one is not the 26,000, it's the 4,800 cubic inch firing chamber of the TPS. One thing to note here is the appearance of the ports. So these are the ports of the TPS and these are the ports of the airgun. And if we zoom up a bit, we can see that these ports are closed. These ports are open, which means that there is a chamber there, which is called the mid chamber, which is flooded with water. And when the air, before the air can start coming out of the ports, this water have to be ejected out and it creates cavitation. So the air guns have open ports and there is a mid chamber, which is water filled. The TPS have closed ports and the mid chamber is air filled. This is another picture where you can see the ports more clearly. This is a close-up of the ports of the TPS. And this is an airgun. In fact, this is an e-source where you can see that it's flooded with water. This is the mid chamber of the e-source. So as I said, TPS is a broadband source, and Mike said it as well. You can put a large chamber. Right now, our largest one is 28,000. We tested it down to 600 cubic inch. If you put a small chamber, you get a good mid-frequency source. With a large chamber, it's a low frequency source. Now, currently, the demand for TPS is basically 100% geophysical, motivated by the need for low frequency signal. And so far, we had no environmentally motivated customers. And this is simply because airguns can also provide the mid frequencies, and airguns are plentiful and are fully depreciated. In fact, there are more airguns than the world need. So you can't come in with a new source if you have such a low-cost alternative, even if the low-cost alternative has a higher environmental impact. So with that, let's see some data, and I'd like to show some data from the Gulf of Mexico. And I would like to show sound pressure level first in the time domain, and again, it's a common receiver gather, so it's ocean bottom nodes. I'd like to display the data and then plot the maximal sound pressure level in every offset, and then we'll go to spectra. So here is a common receiver gather, an airgun shot line. This is full band, it's not high cut like before. It's time going down to 40 seconds, and it's offset going up to 54 kilometers. So from -20 kilometer to 54. And this is the current shot, this is the next shot, and this is the previous shot. And the gain is such that the data are clipped at 50 Pascal. And now I will show the TPS with the same gains, and you can see that it's washed out. This is the current shot, this is the next shot, this is the previous shot. So you basically see the same, but if you want to actually see the signal, you have to gain it up by about a factor 10, in fact. And this is the sound pressure level, the maximum in every shot. Every shot is a trace. So in red, it's a 5,000 cubic inch airgun array. it gets to above 7,000 Pascal. And in green, it's the TPS, 26,000, and it's about 600 Pascal. So there is a factor of about 13 between them in maximum. And it goes, of course, in far offsets, the difference is not factor 13 because you have also ambient noise, and the far offset is more low frequencies, which propagate faster. But in the near offset, it's factor 13. Let's look at some spectra, and what I would like to do is overlay airgun array, single TPS, and noise. The data are from continuously recording ocean bottom nodes, so we have plenty of noise, and we can we have good estimate of the spectra of the noise. And one thing to watch is the frequency at which the source signal is the same as the noise level. So let's look at the nearest offset we have, which is 500 meters, because the shot line didn't go really straight above the nodes. It went 500 meters to the side. The node was deployed at 2,800 meters, so the distance is 2,900. So this is the distance between the shot to the node. And we have the airgun in red, the TPS in green, and the noise yellow. And one thing to notice is this is the frequency, and the frequency goes up to 50 kilohertz because this is a special node which is sampling every 10 microseconds. So we can sample signal up to 50 kilohertz. For comparison, the production data is 2 millisecond sampling rate, and the maximum frequency we can sample is 250. Near field hydrophone data and also modeling data is usually 0.5 mil, and it gives us up to 1 kilohertz. So this is at 500. I showed this to Brandon maybe a month or so ago, and he said, wow, this is interesting. How far are these high frequencies propagate? Because we can see that the airguns generate output up to about 25 kilohertz, maybe a little bit more. The TPS is basically done by the time we get to 2 kilohertz, maybe even 1,500 hertz here. So I asked a friend, well, a colleague in Sarcelles to do the same analysis for a few offsets. And I have time to show only one offset, which is the 15 kilometer. And really, this is now 15 kilometers away. We know that there is little attenuation in water, but at 25 kilohertz and 15 kilometers, it doesn't really get through. So it got to here, now it gets to just 1 kilohertz. The TPS is just basically over at 140 hertz. So with that, I'd like to summarize. First of all, size does not matter environmentally. We saw that the 26,000 cubic inch is environmentally friendlier than the 5,000 cubic inch. It does matter geophysically, of course. We saw that the signal that we need, the low frequency signal, is much better. But environmentally, the size doesn't matter. What matters is really the design of the head. Sources which use the same heads have the same environmental impact as conventional airguns. The TPS, I don't have comparison of eSource and Blue Pulse, but it's a little bit similar story. TPS compared to standard airguns, longer rise time, lower slope, less high frequencies, no cavitation, or at least less cavitation. So we see that the maximum frequency went down from 25 kilohertz with airguns to 2 kilohertz. And by the way, the modeling does not model the cavitation, and 0.5 millisecond, 0.5 mil data from near field hydrophones do not capture cavitation, which is above 1 kilohertz. More summary, this is more like, hopefully we'll get into it in the discussion. We should take the design and the number of the heads into the account, not the total volume of the chambers. In fact, the chambers don't matter. What matters is just the type of heads and the number of heads. And we should record high frequency data. To get 25 kilohertz data, we need 10 microsecond sampling rate. And we need to look at sound pressure level, I didn't list here, but SEL as well, of course. Rise time, slope, which is the ratio between them. This is important because this is related to the particle acceleration. And it should have consequences on permitting and mitigations. As far as I know, permits are given on a first come, first served basis with no regard to the environmental impact. The exclusion radius, as far as I know, is always 500 meters. Sometimes it varies from country to country, but it doesn't vary from source to source. There is a time limit on the permits. As far as I know, it's always 65 days, and no matter what the source is. And then there's no reason to reinvent the wheel in Brazil if the wheel is well invented here. But the mitigations are very different in Brazil than the USA. So maybe a forum like Game On can influence both governments and both bureaucracies. And with this, I'd like to finish. I have some spare slides that we can go back to in the discussion if we need to.
That's great, Shuki. Thank you. And I'm noting that there's a few questions in the chat, one for Mike, one for Shuki. If you guys can, I see Mike already got to his. Yeah, if you can answer those in there, we'll make sure we pick up any as they relate to the discussion topics. But let's keep moving, and we'll have our last speaker, Jill, come up now.
I'm off mute. Okay, here we go. Okay, so what I'm hoping to do today is sort of give you a little bit of a regulator's perspective, I should say, as to how we're thinking about regulation and management that would probably drive the need for quieting technology. So just to give you sort of a bit of an idea of kind of where I come from, where I work at the Bureau of Ocean Energy Management. So we are in charge of managing, offshore energy and minerals, as well as now carbon sequestration in the US EEZ. But we have mandates in our statutes to do this in an environmentally responsible way, not to cause undue harm. But we also work very closely with our sister agencies such as NOAA, Fish and Wildlife Service, so that we can try to manage acoustic impacts together from the activities that we regulate. So we kind of wear two hats, I would say, within BOEM. One is obviously the facilitation of development, and the other is the doing so in an environmentally responsible way. So I'm going to give you a couple examples, starting more locally at one jurisdiction and then moving up to the international level. So in the US, we have two statutes that deal with marine mammals. We do not have any overarching statute or directive that's focused on noise. So what we are doing is using the available statutes we have to try to manage noise from that perspective. One of the biggest ones is the Marine Mammal Protection Act. Interestingly, it manages at the stock level versus a population. There are criteria, which I'll talk about in a second, for acoustic threshold criteria that are used to try to determine what the impact will be to marine mammals from acoustic sources. Level A represents the onset of PTS. Level B considers the onset of TTS as well as behavioral disruptions. But the point here is that, we have a lot of agencies. There's about 15 different agencies that have some mandate in the US over some ocean activity that is causing or putting or managing noise in the environment. So yet we don't have any sort of overarching target or goal that we're all sort of headed towards. So it makes management very, very difficult, but not impossible. I think all folks here are probably familiar with NOAA Fisheries, or National Marine Fisheries Service, same organization, the 2018 acoustic thresholds that came out. So what we largely do in the US is we'll analyze an activity to determine where do we think different sounds, what are they going to result in level A impacts? Are we going to have what is the potential for permanent threshold shift? What's the potential for behavioral impacts and temporary threshold shifts? And we go through a notably complicated modeling that looks at the sound source, looks at the propagation of the sound, looks at the various factors related to the biology and life history of the animals, and tries to in the end come out with take numbers. And in order to get an authorization in the United States from the Marine Mammal Protection Act, your take has to be small in numbers and no more than a negligible impact on the stock. Our Endangered Species Act also has some similar requirements. In addition, the ESA does also have a habitat feature in it. So we are sort of using all this information, but still the same as the rest of the world, circling around what is considered to be small in number. In our case, I think NOAA often uses 20% of the stock, but that's not a set in regulations nor used in every situation. But like the EU, we are also trying to figure out what causes, what does a population level impact look like, and how can we figure it out with the information that we have. So if you look internationally, there are a number of agreements that cover many countries, anywhere from 3 to several hundred countries, in these under these various agreements. And back in 2019, my colleague, Dr. Erica Statterman, and I did just a little analysis of all of these agreements and what the various factors of what they included in there. And you can see highlighted here in green is which of these agreements speaks to quieting technology. So not just to reduction of noise, but actually making things quieter. So if I flip over to the European Union now, I think a lot of folks here are probably familiar under the Marine Strategy Framework Directive. There is a descriptor of 11 that does focus on noise. Under that, what the goal here is, so there is a target of sorts set qualitatively, I should say, but not to exceed levels that adversely affect populations, and set these levels through cooperation at the EU level, but considering there's regional and sub-regional specificities. So like the US, there's still that don't exceed levels that either adversely affect populations, or in the case of the Marine Mammal Protection Act, that are, do not exceed a more than negligible impact on a stock. So that still has to be defined under both of these regulation approaches. So phase 1 of this was to establish these registers for impulsive and monitoring programs for continuous noises. And there's some examples there to sort of get that baseline information about how much noise is being introduced into the environment. And then phase 2, which a lot of the EU countries are in right now, is to decide on policy targets. So what exactly would it mean to meet that do not exceed levels that adversely affect populations? These are supposed to be due and defined by the end of 2022. I don't believe there's any exact policy targets that have been released at this point. I may have that wrong, but I could not find any when I come through. There's also a TG, a working group there, a noise, that has recommended sort of a generic stepwise assessment approach, and trying to get that, how do we get to that adversely affect populations question? And the TG noise did put that out very recently. So it has it sort of pulled together a lot of similarities in many methods that have been out there. And what it's meant to do is for regulators to have some sort of standard they're working with to do the analysis to get to their conclusions about whether there is an adverse effect to a population. And so a quick example of how this might look is, and this is just one way of doing this, is you would define an A, a management area, and B, you will look at the population density of a particular species of concern. You would then, using the information from the registers for impulsive noise, you would do a noise pressure map. So you would come into these pulse block days, which would tell you when there's more noise and when there's less noise. You would overlay those into a risk map that sort of puts together the higher intensity noise days or pulse blocks with the higher density. And you would have come up with an exposure curve and indicators and eventually an exposure index. And so from that exposure curve on B, you could come to an exposure index on A, and then a regulator could decide, okay, we're only going to allow 25% of the population to be exposed at 25% of the time. And on the left blue bar there, there's a lot of different ways these targets could be set. So you could limit the percentage of the population exposed per time and then set a maximum at that. You can limit the percentage of the population that can decline as a result of the activities. You can limit the number of maximum pulse block days within a specific habitat. And there's other approaches that are being considered as well. So this is a little bit of a long way of saying that in the US, in the EU, that there is a move in the direction of setting these targets. But it's challenging to determine, to have all the data you need to determine what is going to be a population level effect and have a real good clarity on what your target should be. And the other thing that I would note is there are other jurisdictions that potentially have even stricter targets. For example, in Australia, with the blue whale conservation and management plan, there's a large sanctuary area in south of Australia. And not only do you have to avoid PTS and TTS there, but you also cannot do anything that could impact foraging. So that takes it down to a level B impact as well in regulating to avoid level B. So there's a recent paper out, fairly brand new, Merchant et al. 2022, where they basically went and looked back at the last 10 years of applying the Marine Strategy Framework Directive. I'm focused here on some points that were made in there as they relate to quieting. So the alternate approaches to defining good environmental status thresholds will be necessary. I think there's an acknowledgement in there, as I've been speaking to, that we are getting better at coming up with methods to get to population level consequences, but it's still going to be dependent on data, and we are currently data limited, not for all the animals or species, but for many of them. The paper also notes that measures to reduce noise levels have been limited. They note an EU Commission 2021 report that speaks for the first time about the explicit need to reduce underwater noise. It also speaks to reviewing the Marine Strategy Framework Noise Directive for possible noise cap. They related to sort of a beach litter cap that they have done in another instance, where in that case they said you can only have a certain amount of litter available over a certain distance of coastline. So delivering on that EU report will require further research on the development and implementation of quieting measures, and that could be technologies or could be methods. And the paper also noted that while these alternatives have been developed and tested successfully, none seem available at commercial scale, and the paper opines that it's due to a lack of regulatory incentive to encourage their use. So just to summarize, there is a clear and growing regulatory trend to set thresholds for noise limits or activity caps. I think you're seeing that certainly in the EU. You're seeing that driven by other countries as well, including the US is contemplating how something like that might look. One of the big reasons for that is, as a regulator, it's difficult to determine what constitutes that adverse effect or what taking in small numbers is. Getting there to answer the question of where a limit should be set adds a lot of complexity in the analysis. And therefore it provides a lot of regulatory unpredictability. And how long, if you can't figure that out, how long does it take to issue an authorization? If you use the best available science, which is what we are charged to do on most of our statutes, it still can make it, right for litigation as well. Use of quieting technologies or methods could greatly simplify this challenge. We still do need to be finding out more information about the species that could be impacted and how they're impacted and if they're impacted and so forth. And so we still need to be doing that kind of thing, but having sources that have a less impact on these species off the bat could greatly simplify the assessment approach and provide more permitting certainty, as well as decisions around permitting that are more sustainable. And I would also say it's unclear why it is taking so long to regularly operationalize quieting. I totally understand that it is perhaps a more challenging problem for trying to get seismic data than it might be for other things that are being quieted. I know that we have been hearing about a number of these sources over a bunch of years, but I will note that in the prior two presentations, there were more sources in there that I had not heard about, or more techniques and more technologies. So it sort of obviously makes me think that maybe regulators are not as aware of these different sources and how they can be used as we need to be to make some better decisions. I will say that we've also been following along the marine vibroseis development, particularly with the JIP for a number of years. I know that was started back in 2011 by ExxonMobil, Shell, and Total, and they've been very good about engaging with us to give us updates, explain the approach. But we are at a point, right, where we need to have more tools in the toolkit to be able to manage this more effectively from an environmental standpoint. And so I'll just end with questions that I think about when I'm thinking about how can we make this more effective. And in me, effective means reducing the environmental impact while still being able to get the data needed by industry. So there is a fine line there, and depending on your perspective, that line may be in one place or maybe in another. But I do think, we need to really focus on what those answers can be that can get us to getting the data that we need, but also the seismic data that we need, but also doing it in an environmentally responsible way. The roadblocks, challenges, what are they? What can governments do to better incentivize? What can industry do to better operationalize these? How do you bring this change to an industry that has been reliant on existing technology such as air guns for a while? And one thought that I have in my mind as well is what might a performance target look like for air guns? So instead of having the government, plural, say, you shall use this source or that source, how might we collectively and even internationally come up with a performance target or performance targets based on particular situations where industry can take that and figure out how they get to it. We would set it, they would figure out how they get there. So those are the questions I have in my head, and I'm done. And so open for any questions folks may have.
Thank you, Jill. So I think what we're going to do is just take a short break. We'll give people just a couple minutes. It's exactly the top of the hour. We'll give people 5 minutes for a quick bio break. We're on time. I would just you could keep your questions up during the discussion or during the break, just for people to look at. There's been a good amount of things in the chat. There's some questions in the Q&A. So we'll reconvene at 5 past, and Doug will introduce the panel discussion, which will include the 3 speakers as well as a number of other people that Doug will introduce. And for those people that could address some of the things in the chat or in the Q&A, go ahead and do that, and then we'll do our best to make sure that we pick it up and pick those things up in the discussion. So yeah, we'll just take just a few minutes, and Doug will kick us back off after people have had just a short break.
All right, everyone. I think we'd like to get going with the panel discussion. And Jill, if you wouldn't mind pulling down, that's perfect. And then if I could just ask all the panelists to go ahead and turn your cameras on. We'll have everybody on for the duration of the discussion. So thanks again to Mike, Shuki, and Jill for those presentations. There's a variety of things going on in different chats and Q&A boxes, so we're trying to keep track of it all, but in fact, I think it looks like the panelists, including me, have actually learned some things today. So that's a good start, a great start, actually. A big thanks to our panelists from across the globe. Well, I don't know whether we have anybody from Asia on today, but anyway, we have quite a nice representation of folks. So thank you for joining us. And we'd like to leave some time, a lot of time for discussion and idea generation and generating some action items. But we do have some questions to prompt through it, but we'll start with a panel introducing themselves. Briefly introduce themselves, name, your role, and affiliated organization before we jump into questions. So if I could ask Jolie Harrison. Jolie, if you could start us off. Thanks.
Sure. Hey, good morning, Doug. Thanks. My name is Jolie Harrison. I am with NOAA in the U.S. I'm the chief of the Permits and Conservation Division in the Office of Protected Resources with the National Marine Fisheries Service. I am responsible for the group that issues Marine Mammal Protection Act and Civil Take authorizations. I also co-lead the NOAA Ocean Noise Strategy with Leila Hatch and Jason Gadamke. Thank you.
Thanks, Jolie.
Good morning, everyone. I'm Alex Lorero. I'm the Scientific Director for the Energeo Alliance. We are the global trade association for the energy geoscience industry. I'm a marine biologist, and my role with Energeo is to manage everything related to sound in the marine environment and how that might potentially impact marine life. So I work very closely with regulators as well as our members and the general public.
Thanks, Alex. Lindy.
Hi, yeah, I'm Lindy Wildgard from Ocean Care in Switzerland and Dalhousie University in Halifax, Nova Scotia, Canada. I've been working on noise issues since 1993. It's my main focus, and I am particularly interested in quieting, and I am just now really right in the throes of finalizing a report on quieting technologies for shipping, seismic air guns, and pile driving. And that will be for the convention, technical series for the Convention on Migratory Species, as well as a chapter for the aquatic noise book that was from the Berlin conference in July.
Super. Thanks, Lindy.
Hi, everybody. I'm Lee Torres. I'm an associate professor at Oregon State University in the Marine Mammal Institute here and with Oregon Sea Grant. I do research on a number of topics, mainly focusing on ecology, behavior, and health of marine mammals.
Thank you.
Hello, everyone. My name is Sonia Mendez. I work as a senior advisor for the Joint Nature Conservation Committee, or JNCC, in the UK. We advise government on nature conservation, and I have been involved in advising on the effects of seismic surveys on marine mammals and also on noise mitigation and management. I advise on casework, but also more strategically on policy guidance and research.
Hi, everyone. Michael Jasny from Natural Resources Defense Council, or NRDC. I direct NRDC's Marine Mammal Protection Project, and I've been working on ocean noise law and policy for more than 20 years across a range of sectors, shipping, oil and gas, offshore renewables, and military. Thanks.
Hi there, I'm Russell Leeper. I'm a member of the Scientific Committee of the International Whaling Commission and also the TG Noise group that was mentioned earlier. And I've done some research quantifying the effectiveness of some of the mitigation measures that are used.
I have.
Hi there, I'm Patrick Miller. I'm at the University of St. Andrews in Scotland. in the Sea Mammal Research Unit, where we focus on mostly seals and cetaceans. And I've worked quite a lot on the effects of noise on cetaceans, particularly sonar primarily, but also some studies of the effectiveness of mitigation measures like the ramp-up procedure, for example. That's one of the standard procedures. Thanks to be on board.
Yeah. Thank you, Patrick. Thanks to all, and hopefully you get a sense of our goal to represent stakeholders from around the issue and the field, to where we can have a discussion about moving towards solutions. So we'll also, obviously, Mike and Jill and Shuki are certainly part of the panel as well, and so we'll get started with and really just open it up to the panel. And again, we'll moderate the questions that are coming in if they haven't been answered. So one topic: discuss and evaluate available and near horizon options for technological approaches to minimizing impacts of noise from seismic and other geophysical exploration. May include, but not limited to, the air guns that you've just heard about, redesigned to produce less noise in targeted frequency bands, and then marine vibroseis. So the goal here is to have this discussion around evaluation of those options for technological approaches, any shortcomings that people see, or bright lights, bright ideas that really seem to really want to solve or make big inroads into this the issue of reducing noise from them in the environment. So I'll open it up to the panel. This is where I did see people. Yep, go ahead, Lindy.
So I wanted to ask about, in the course of writing this report, I was told that there was an IPN pilot marine vibroseis and a BASS, B-A-S-S, vibroseis, that those tests were to be done, I think, in the summer of 2022, or anyway, I just wanted an update on how testing of marine vibroseis has been going. Mike or Shuki?
Yeah, Mike, can you field that, or Shuki maybe?
Yeah. You go ahead.
Mike is the guy, yeah.
Frankly, you may be right about the BASS test. I don't really know. I do know that that an IPN test for the APS unit was conducted just a little while ago, and there is some planning for an environmental test with Brandon in next year. However, I'm not certain about the current status of the other units. I know they're proceeding. I know the Shearwater unit is proceeding, but I don't know where it is in terms of testing.
Yeah, Alex. Oops.
You don't know the results of that test that was conducted?
Sorry, who was that to?
Well, I guess either you or Alex has her hand up, and I should have called on her earlier. Sorry, Alex. Do you have any updates on that? My fault.
Yeah, no worries. I mean, we've spoken with a couple of members that are in the process of developing some marine vibroseis units, but I do want to highlight some of the ongoing research through the Sound of Marine Life JIP. We have 2 studies ongoing right now. One is a laboratory-based study at UCSC with Colleen Reichmuth and Jillian Sills, looking at low frequency hearing capabilities of bearded seals. This is a really exciting one to me because it's some of the lowest frequency hearing data we have for any mammal, not just marine mammals. And then we also have a field study coming up with Brandon next summer, where we're going to actually take the unit out in the field and test behavioral responses of large cetaceans. So I think it's exciting to see these proceeding. It's important to remember that we need to actually get some behavioral response data before we assume anything about the efficacy of marine vibroseis sources. But it's in development. It's not quite operational yet, to my knowledge. As far as I understand, it's not quite to the point where it can be used commercially. But we do expect that to be coming in a couple of years. So it's great that the Sound of Marine Life JIP is ahead of that and getting some data ahead of when those units are available.
Great, thanks, Alex. Follow up. Oh, Lindy's hand went down. Okay, Michael.
Thanks, Doug. I have a similar set of questions about the TPS systems and whether they're presently in commercial use. It sounded from Shuki's presentation that they indeed may have passed beyond testing and be in commercial use in order to fulfill certain geophysical objectives. Is that correct? And how widely is it used?
Yeah.
Yes, it's commercial. It hasn't been used a lot. We did two, I shouldn't say surveys, we did two tests that where each of them, I mean, combined, it was a few tens of thousand shots. And we have a backlog of one confirmed survey, which, by the way, will be pure TPS. There will be no air guns on that. That will be at the beginning of 2023. Sercel has built an inventory. I think we now have 8 heads and for 28,000 chambers, and we will use all of them. 6 and 4 we will use in the next survey. We have a lot of interest, and it's, by the way, worldwide. A lot of it is in the Far East. So we expect to have a lot of business next year. So far, Sercel has invested a lot in TPS and did not really so far get any return. So it is commercial, but it's just starting.
So, and just to follow up, are there any other firms manufacturing similar systems?
As far as I know, there isn't any new head, with the exception of eSource and Blue Pulse. There are the low frequency, basically clusters that Mike and I mentioned. So these are low frequency sources, but they're using current technology. They're not using new heads. The Russians, interestingly, have about 10 years ago, they came up with a cluster. It was a company called Geology Without Limit, GWL. And they kind of had a cluster that provided low frequencies from current technology. With, according to the picture, it was not it was air guns that were manufactured somewhere else, probably in Russia. They are not really commercially, they're not active. So I think the TPS is right now unique in the sense that it's a new head, designed for lower impact and also for large volumes. Because every head, including the TPS, has a limit of what the maximum volume that it can emit as a seismic source. Because if the volume is too large, it will not be a seismic source. It will just be a pipe releasing high pressure air into the ocean. The airgun limit is probably about 2,000 to 4,000 cubic inch per head. The TPS is well, we know the 28,000 work well. So it's probably something like 40,000. And this is a specific design of the head to be able to emit large amount of air.
Thanks.
Thanks, Shuki. Yeah, Lindy.
Thanks. Yeah. So similar to what Jill had in her presentation, I was wondering why, since the marine vibroseis has, I think, started more serious development by the JIP program since 2008, and here we are 14 years later, and it's just incomprehensible to me how long this has taken, especially if you compare it with the pile driving quieting technologies. Those have been rampant and immediately used. And the main thing I can see as a difference is that countries like Germany required it. And so without a firm regulation requirement, nothing seems to get done. And just the fact that, I mean, these are very exciting developments, but this is like my major push, and it's like pulling teeth to try to find out this information. And I'll need to follow up certainly with Shuki and Mike to get this into this last version of the report if you want it in there. But yeah, it's just how can this be taking so long?
Yeah, that's great, Lindy. And if I could just to throw it out to the panel, this question is specifically about the technology, but if there are other thoughts on it, whether it's regulatory or operational, folks, please do chime in. But Michael and then Alex, thanks.
Well, I think I have the exact same question as Lindy. I was going to bring it up later. I'd really like to hear Jill and Jolie's response to it, but I'm happy to chime in afterwards.
Thanks, Michael. Alex.
Yeah, this is probably quite obvious, but I think one of the important factors to remember here is that with pile driving, for example, the sound is incidental to the activity, whereas with seismic surveys, the sound is the activity, right? We need that sound generated in order to accomplish our geophysical objectives. And if you compromise that, there's then no point to actually doing the survey because you're not getting the data that you need. And I know, the geophysicists like Mike and Shuki are much more qualified to speak to the actual nuances of how those sources achieve or don't achieve some of those objectives. But a lot of these technologies are in development, and some of them are proprietary right now too, which means only one company has access to them. So that's been a challenge as well, as how can we ensure that folks have access to these technologies without violating any antitrust or anti-competition laws. But Mike, I'd be really interested to hear your perspective, or Shuki, if you want to jump in, on where maybe some of these technologies aren't quite up to what the standard compressed air source has achieved in the last 50 or so years. I think it really is, it's very different than when we're talking about shipping or piling, where those noise activities are incidental.
Yeah, definitely. Yeah, Mike.
Yes, basically the Marine Vibe JP has been was initiated in its third phase, which is the development in late 2012, and it is a hard problem. Generating low frequencies with a volume displacement source is very, very hard. You have two choices: you put the energy in fast, or you put it in slow. And the great thing about a bubble is that you put a lot of energy in very fast. With its concomitant problems, you're getting frequencies you don't need. I think what should be noted is the fact that we have made a lot of progress. I mean, there's a number of units which are going in development, but what we have found and what other companies have found is that there are engineering obstacles which you have to overcome and are very difficult. So we've had multiple times when we've had to go back, re-engineer some things and go back again. And there are a lot more moving parts in a vibrator generally than there are in an air gun. And so I understand the frustration, but there are engineering challenges, which I think we're getting to the end of. Without a doubt, I think when they become reliable enough to be used, there are significant advantages with vibrators, not just environmental, that would make them very easy to use. And so it's just a question of overcoming those challenges. And I believe there have been a number of tests just recently which are looking very promising, not just with the IPN, but also with Shearwater's one. And there are a couple of others that I don't really know its status of, but those things all together can I think, progress it forward.
Great. Thanks, Mike. Yeah, Shuki.
Yes, well, of course, with seismic, the noise is not incidental. It's this is why we're doing it, but we don't need the high frequencies. That's why we don't get the high frequencies back reflected, and that's why we sample the data with 2 millisecond sampling interval, which means that we're not going to record anything above 220 hertz, which is 250 minus 10% or so. So we have a lot of scope to reduce the high frequency content of any source. And the industry has started with it with eSource and then TPS and Blue Pulse. And I think this will continue. And of course, vibes are completely controlled, no cavitation. And I'd like to second what I heard before is that these new technologies are more expensive. Probably vibes are more expensive to introduce than TPS, but any of them is more expensive than continuing to use the same airguns that we have, or just to change the shuttle, which is less ambitious. And I don't think it will happen if regulators are not going to recognize that that these technologies are attractive in a way that just the commercial point of view is not considering right now.
Mm-hmm. Right. Yeah. No, it's good. Good direction for that, for part of that discussion. Thank you, Shuki. Russell.
Yeah, just following up on what Shuki said there, I think one of the things that could kind of motivate the uptake of quieter sources is through regulation, and most national guidelines do require operators to use the minimum level of source, but there hasn't really been much way of quantifying that and for operators to come forward with really detailed plans of how they really are using the minimum source. So I think that's something that could be developed much more in terms of a dialogue between the operators and the regulators in order to really demonstrate that the new technology is being used to the best it can, and the minimum source levels are being used.
Thanks, Russell. And are you thinking in both using minimum air guns, traditional air guns as necessary, and then also transitioning to these other sources as well?
Well, I think it can do both. In the short term, there may not be another source that meets the requirements, but there may be ways to configure the air guns using some of the technologies that we've heard about today. But I think the next step is clearly to use the new technologies as well. And so if there are limits set on the maximum sources that can be used in certain situations, then that could help promote the development.
Yeah, perfect. Thank you. Jill.
I was about to say the same thing Russell just said. Yeah, we do have things obviously about lowest practicable source levels, which I know is a piece of the equation, not the whole thing. But what struck me in listening to the first two presentations was how many of these potential sources or methodologies that I did not know about, right? So I don't know, I would leave it to Jolie over at NOAA to answer that question from her perspective. But I think one of the things is there are some companies that are really good about talking to regulators, and others that it just hasn't come up on their radar yet, or perhaps, I get there's a danger of sorts in speaking to a regulator about something that you're developing, but there needs to be, I think, more communication. And I just wonder, what is that? Would performance targets be the thing that could get this over the finish line? I know it's never quite 100% finished. And I understand that these different techniques or sources can be used in different areas. There's not a one size fits all. But it does seem like we might be at least not totally leaning into that lowest practicable source requirement.
Yeah. Thanks, Jill. Alex.
Well, I'm glad you raised that, because I just want to blanket offer to you and Jolie and Sonia as well. If we want to try and get something together to wrangle our membership to share some of this information with you, give me a call. Let's work on something there so we can be a little bit more proactive about that.
Super. Others? Yeah, Lee. Oh, Michael. Lee first. Sorry, Michael. It was like you're muted, Lee.
Sorry,
Okay.
unless Michael wants to comment on that topic, I was going to change.
Are you going to change topics a little bit? Michael,
Yes.
do you want to say something on there?
Yeah. So no, I thought this has been a really useful conversation, and I just wanted to, before we leave the topic, pull one important kind of strain together from something that a few people had said, in that, you know, there is an economic hurdle to get over here that it seems to me to be, based on the presentations we heard at the beginning, you know, more important than the engineering and operational hurdle, at least for some of the technologies that are presently out there. The fact is that you have an industry that is highly competitive, and one in which you have an existing technology that is readily available, and I think, as Shuki put it, already fully depreciated. And in that context, it is going to be very hard, without some kind of regulatory intervention, to get broad adoption of new or of technologies and methods that can hope to achieve a lowest practicable source level or other kind of standard. For anything ambitious, it's hard for me to conceive of an incentive that can overcome that kind of barrier. I mean, that is for switching from airguns to something novel like TPS or vibroseis. And for that, I think you need to look at setting some kind of regulatory requirement, like a target, just as Germany did with offshore renewables years ago. I think given the competitiveness of the industry, given the existing buy-in to air guns to effectuate any any broad adaptation of some of the technologies that we've been discussing here, it's going to take regulatory intervention. It's not surprising to see that was the conclusion of Merchant et al. As well. Thanks.
Yeah, thanks. Mike, is it on this, or you ready to? Lee's going to switch topics, so you got some thoughts on this? You're welcome to. Yeah, you're muted, but
yeah, it's just very quick that things which may seem simple, like choosing the right airgun size for output for an area, actually are much more complicated than they seem, because when you choose an airgun and then the weather deteriorates suddenly, so you're either running larger than you need to be to take the worst case scenario. And so it all depends how these regulations fit in with the way that operations occur. So a source that may be perfectly good in certain circumstances, in other circumstances is not. And so you have to look at that when you're looking at regulation. I agree it's something we should be aiming towards, but it's often more complicated than people think to do these things. And that's all I want to say.
Yeah, no, that's a very good point, and I think that's where we have smart people in these agencies is we're lucky to have that. I think we can figure it out. Okay, Lee.
All right, thanks. So some of the research that I've been doing here looks at the physiological response of whales to noise variable soundscapes. So we collect fecal samples and look at their hormone levels. And we've been doing this for a number of years, and a lot of what the soundscape is in our study area is driven by boat-based noise. But we did have a seismic survey come through the area, and the closest approach was about 25 kilometers, so not very close. But in looking at the results, so our preliminary results, it does look like there is an increase in stress levels, so cortisol levels at the beginning of the seismic survey. So pretty much at the closest, loudest approach at first, and then it declines off and doesn't seem to have much relationship even when the seismic survey came back around again and so forth. So I was curious about the discussions about the new technologies and the the rise up, I think is what the term was that was used, the increase in that. And so I was wondering if anybody could talk to what exactly that meant in terms of increasing the temporal window at which that happens, or the speed. I didn't quite understand that.
Yeah, just for context, so this is the rise time of the signal out of the guns. Yeah. And typically sharp rise times lead to broadband signals. So Patrick, do you mind if I solicit a thought on that from Shuki, Mike, or Alex on the rise time issue? And the TPS has a slower rise time, is that right, Shuki?
Yes. So the rise time is how many milliseconds basically it takes between between triggering and the air starting coming out are a few milliseconds. But once the air starts coming out of the ports, how long does it take for the main pulse, which is the highest sound pressure level, to reach its peak? And airguns were designed by invitation to be just like dynamite. So they have a very short rise time within a millisecond or a fraction of a millisecond for the small ones, and a millisecond and a half for the larger ones. They would reach their peak. That each airgun the peak is about between 3 and 5 bar meter. So the slope is about 3 bar meter per millisecond. Now, it doesn't have to be that sharp to provide the geophysical necessities. In the 1960s, it was thought that it's needed. But then, as Mike said, we found that actually we don't really need it, and we just get as good data if instead of a millisecond and a half, it will take 5 milliseconds or 10, and we still get low frequency data. Well, for the high frequency data, we do need a short rise time, but for most of what we do, we don't need the short rise time. And the e-source and blue pulse do address it. So instead of 3 bar meter per millisecond, they have maybe 1.5 bar meter per millisecond. TPS has 1 bar meter per millisecond. I think Lindy asked me on the chat the same question, and I answered that I wished I could put a picture. I don't think I want to share my screen right now, but I will share my presentation, and one of the spare slides shows exactly that. The rise time and the slope of TPS and with various volumes, in fact, compared to an airgun recorded apples to apples by the same near-field hydrophone.
Super. Thanks, Shuki. Alex, quick on this, or
real quick, I don't want to interrupt. I just want to clarify one important point. Shuki mentioned that it's just like dynamite, but I want to clarify that it's just like dynamite in that it's a very short rise time. There's no shockwave like dynamite. I see this get picked up and confused often. So just to be clear on that, it's similar in that it has a short rise time, not in any of the other factors. I just want to make sure we're clear on that.
Yeah, no, it's good to clarify. Okay. Folks who think about the other part of Lee's, what Lee raised in terms of the stress, we can maybe go back to that. But Patrick, please, thanks.
Yeah, I was also, I learned a lot from these presentations. So I really thank all the speakers for what you brought forward. And the rise time is a particularly important factor in how some animals respond to noise. In fact, there's a startle response. That's a well-known
reflex.
Innate reflexive response, exactly that. I'm just curious if what we're talking about rise times are actually relevant to this possible physiological response, because that there are particular parameters that define the rise time to lead to this physiological response in animals. And maybe what we're talking about here is still so quick that it still would trigger a startle response. But I'm just curious if anybody has thought about that. The rise time, it seems like the primary motivation is to reduce the high frequency components, which makes sense from the physics. But has anybody looked at that in terms of the biology and the startle response? And if not, I would just say that perhaps that's a good action item for someone to put on a list, to have somebody look at the details of what we're talking about, the rise time and the frequency spectra, what animals there's going to be maybe some taxa groups that might be particularly relevant for.
Yeah, very good question. Not that I know of. The startle response is tricky to measure, and especially in large whales. Yeah, Brandon.
I was just going to kind of add to that, the rise time issue and the high frequency issue, in addition to the startle response, has pretty big bearing on some of the issues related to hearing thresholds and impulsive, non-impulsive criteria too. So we lack some of the right kinds of key biological data to be able to kind of, know for sure whether we're talking about rise time or peak pressure or crest factor or kurtosis, which is probably the right one, and people have proposed it. But there's some clear needs to get the kind of data that Shuki showed at high frequencies at long distances, to look at this decay at certain frequencies. We had proposed a pretty simplified sort of proxy approach based on high frequency noise above 10 kilohertz as kind of a coarse metric of impulsiveness, given that we don't have some of these detailed measurements of kurtosis. But I was just going to add to what Patrick said, is that there's some real research needs that are tough to get to in terms of some of the hearing data, just because of the nature of doing these types of studies in enclosures that have highly complex, interactions of pressure and particle motion and the kinds of things we would need. But that it's just a really important thing to be able to continue to measure those types of curves that Shuki had, I think are really critical to get that key data. And then, there's either some simplifying kind of things we could assume, or some actual empirical things on responses. And maybe there could even be dovetailing some of those startle responses with measurements with some of the hearing measurements.
Yeah. Thanks, Brand. Yeah, Lindy. Then we're going to pivot to regulatory issues. Go ahead, though, Lindy.
I just wanted to double check. I mean, isn't a sharp rise time also, from an auditory point of view, not a behavioral one? Isn't that more damaging?
It is, and that's why the impulsive criteria have lower SEL values associated with them. It's just this issue of where something that was impulsive stops being impulsive from the perspective of animals is such a key point, because on the one hand you get you could just be conservative, which is what we recommended in the 2007 paper initially, and just assume impulsive sort of forever. But as you saw from some of the things Shuki showed, you start to lose those features, especially with some of these other ones that probably tell you to switch to the non-impulsive criteria. But we've just kind of been debating within the field and with some different interpretations of that, of how to make that balance right, given that we don't have the kind of data that you have for humans to be able to do that. Even for people, there's still some debate about some of these issues, but there's kind of a running debate in the literature over this topic. But I'm just suggesting maybe we could combine some of the startle and the auditory measurements. But unfortunately, to really do some of these things right, you need the animals to be in the ocean. It's just really hard to do in tanks to really do them properly. So
yeah,
that's been done with hearing data before, but it's challenging.
Yeah. If we could, I'd like to pivot to specifically addressing some of the regulatory things. And this impulsive versus continuous is one of them. But there are some questions that Sonia answered in the Q&A. Thank you. And I think Jolie piped in, and so did Jill. But what are the what's the horizon for some regulatory ideas, action, requirements that could bring some of these things actually into the field? And given the uncertainties with some of the animal data, it's understandable. But just give us maybe a scorecard of where we are, and at least in the US and UK, that we have well represented on the regulatory side. Any thoughts on where we go? Yeah, Sonia, thanks.
Yeah, so one of the things that Jill mentioned and some others kind of asked about it is the area time limits on noise in certain areas. So we've kind of been trialing that in the UK in harbour porpoise marine protected areas. And so effectively that's like a noise quota that cannot be exceeded. So it's 20% or 10% of the area over 6 months, over a season, cannot be insonified. So so that has challenges, but it has been working. And it sounds like TG Noise advice is to kind of roll that kind of system out more broadly in the member states' waters. So that's that is one kind of approach. But I like many, was really surprised to hear about all these engineering adaptations. I didn't know many of these existed, and I was still kind of unsure about whether are they used just because it optimizes signal, or are they not used? They're just out there and they were developed not so much for technological reasons, but also for environmental reasons. And there seems to be a lot of complexity as well, like Mike mentioned. So one of the things that I thought maybe I could take back to my regulators as advisor is, do we need, and this is maybe something we could collaborate with Jill and others, do we need a kind of inventory of all these different engineering adaptations, and what are the constraints in terms of application, what are the actual noise reduction advantages, what are the evidence gaps, so to identify maybe the most promising solutions. And then maybe Russell mentioned this, in the kind of the licensing process, to more explicitly consider some of these engineering adaptations. The regulator could perhaps have some standards of things that operators need to discuss. Why is this airgun array being used in this way? Could they use some of these engineering adaptations in this circumstance? So maybe that can be kind of explicit during the regulatory process. I don't know, this is just some of the ideas that I got whilst listening. But at the moment, yes, there isn't in the UK as well that kind of regulatory kind of threshold or limit for seismic. There might be one coming for piling, but follow on what Germans have done. But yeah, there is a little bit of an inconsistency there with other industries that perhaps needs looking at.
Yeah, well, and I will just point out, of course, that the piling is impulsive, but also has this issue of how far downrange is it still impulsive, and then things like vibratory piling, which are considered a continuous source. So we have that same issue, same questions. But yeah, Jill, and then Jolie, thanks.
Yeah, I just want to reinforce one of the things that Sonia just said, and I think that we need to have greater communication with industry, for sure, so that we are regularly hearing about new things, but also progress on some things that we might hear about, and then a year goes by and we don't hear anything else about it. I also think we need to be doing this more globally. I think that perhaps there could be an incentive as well if regulators were settling around, consistency and how we were regulating, or at least, managing this issue as far as we can be consistent with our various laws that are different in different places. But that brings predictability. So industry knows, okay, if we're, it's not going to be, a different issue here, a different issue there, a different issue there, a different issue there. But if we could come together and at least kind of lean into what can be done now and how could it be done and share that, I think it would be, it would advance this. And it would help regulators understand how they could incentivize it better.
Yeah, very good. Yeah, Jolie. Thanks, Jill.
Hey, thanks, Jill. Yeah, so I guess first just to follow on what Jill just said and maybe take Alex up on her offer. This stuff does move forward quickly, so and offer Alex to write down and discuss where each of these technologies are, whether they fully replace another one in terms of what operators need to accomplish, and that sort of thing is always good. So I appreciate that offer. The other thing I sort of want to get into, it's hard to articulate, but obviously having regulatory requirements in place is probably what gets people to move to a certain place more quickly, in many times than other things. I do just want to point out that, certain existing regulations in the US and elsewhere have different strengths and weaknesses and things that they're more successful at accomplishing than other things. And I guess one of the challenges that I feel like we have in the US with at least the section of the Marine Mammal Protection Act that I implement, for example, which relates to incidental take and is focused around sort of some species specific findings that need to be made for individual activities. Sometimes it can be challenging to use certain pieces of existing statute and regulation to accomplish different things. So for example, folks that are familiar with the sort of authorizations that we do, operational quieting in the context of a specific activity and a particular species that has something going on in an area, that's the thing that we do utilize. I know, obviously through encouragement, obviously we're always trying to push the use of quieter technologies. And in fact, if people were to do that, sort of a logical outcome of that is if an activity is producing less noise to begin with, there's probably going to be less impactful mitigation that is required to reduce the impact of that noise. So there's some logical things like that follow. But when it comes to sort of the broad global reduction of low frequency noise, or lower frequency noise, which I think is the biggest concern for behavior and population level impacts, I think I'm really excited to hear some of the things that Jill is talking about with quieting metrics and sort of their priorities on that front, because I think that not that you can't have regulatory overhauls and whatnot, but there are a fair number of challenges with mandating, at least from the provisions that I'm responsible for implementing, that folks use a completely different piece of equipment. And so while we encourage that and we try to point out the sort of regulatory benefits it might have in our current paradigm, it's harder to just say we're going to absolutely make that happen. And I do think that being able to have perhaps some requirements related to the agency that permits the activity, which in the case of seismic is BOEM. I'm excited that BOEM is thinking about the opportunities and tools that they might have to sort of make some of that work. And so, yeah, I guess I'll just say that there are challenges. Certainly, we do what we can, and obviously what Jill said about collaboration and working together continues to be true in all cases and trying to make all things work. So I'll just stop there.
Thanks, Jolie. Michael.
Yeah, I just wanted to maybe build on a suggestion that Sonia made, which in turn I think was building on another comment about increasing communications and then trying to incorporate consideration of these new technologies within the regulatory process as regulators try to deal with applications coming into their systems. And the point I want to make is just that if you are trying to come up with targets that apply generally, or if you are trying to trying to engage with a would-be permittee more prescriptively over what kind of technology or operational measure they should employ. It's going to be important to have some geophysical expertise within the agency in order to make that happen. If you don't have that geophysical expertise when you're communicating with industry, you're dealing with the problem of asymmetric knowledge, and you've got a biologist trying to communicate effectively and in a way that's respectful but also challenging on issues of practicability and operational feasibility with people who have far more knowledge in that department. So I would just say for that kind of communication, whether you're doing targeting, trying to come up with generally applicable targets, or whether you're trying to come up with a suite of operational or technological measures that might apply in any particular instance, I think it's going to be valuable to have some geophysical expertise within the agency that you can rely on.
Yeah, good, very good point. Yeah, Sonia, just give me 1 second. I'd just like to prompt folks on the panel in particular, but also anybody listening, if you have ideas for action items, sticking with our desire at Game On to actually come up with actionable ideas, please put them in. There's obviously some that have percolated up already. So just wanted to prompt. Yeah, Sonia, thanks.
Just quickly, just picking up on the international collaboration point, and this has been mentioned before by you, Doug, and others. Is there any opportunities for an international agreement or convention on, the phasing of airgun surveys? I don't know, maybe this is heresy, but something. There's so many conventions now that explicitly mention underwater noise. So are there opportunities? I don't know. Does anyone have an opinion on that?
Yeah, I mean, MARPOL through the IMO is one avenue. It doesn't apply obviously to anything other than shipping, really. But we're going to cover that in the next series. I don't know. I mean, the law of the sea has a provision to minimize the discharge of energy into the ocean, and sound certainly falls into that category. We looked at that when we wrote one of the papers we have done on the topic. So it really, and from my understanding, is actually when the law of the sea was framed, it said heat, but then was changed to energy so that it included sound. Of course, the US hasn't signed it, so
certainly give a bit more, back into the regulators.
That's right. That's right. Yeah. Okay. Thanks, Sonia. Others, thanks. We're getting a lot of good stuff in the chat, and I apologize to the participants. We're only able to send it to the host and to the panelists, but other ideas. Patrick.
Yeah, just as an action item, the process is clearly going to take time to solve this, and a big part of the puzzle is how effective are these different mitigation or different alternatives at actually reducing impacts. And that's something that we still don't know. There are good ideas, and it's very promising, but we're lacking the quantitative data on how effective these are at providing that environmental protection.
Yeah, no, it's a great point, Patrick, and that's certainly paramount to what we're on about. But also part of the mission is just to reduce the amount of sound in the ocean, right? Okay.
Yeah, but it could be complicated. For example, going to vibroseis reduces that peak pressure level, but then you have a continuous source that maybe masks the communication of a blue whale. So then the effect is different. So it's not always as simple as just quietening.
Yeah, no, absolutely, Patrick. Well, spot on. Yep, thanks. Lindy, real quickly, and then we need to wrap up. Thanks.
Yeah, real quick, we did look at, we did model marine vibroseis, and even out past 100 kilometers, the SELs are lower as well. So it's not quite as much of a, you know, worse in terms of masking. It's definitely better on that side.
Yep, and that also gets back to the need for data, and also a compilation of these sources. Yeah, Jolie.
Yeah, I just want to say one thing. You know, I think we all understand how challenging it is to gather data and learn all the details that we want and need to understand about how noise impacts marine mammals. So I just want to broad reminder: being quieter generally is better, regardless of whether or not we know those details. We absolutely know, and we can quantify the fact that animals could use more quiet space, and I bet there's nowhere that we wouldn't benefit from quieting to some degree, but certainly all of the areas that we're talking about and regularly, still just keep in mind that basically quieting is still going to reduce the chronic impacts on marine mammals, even though we're missing some details for some specific understanding. So I just want to make sure that's clear.
That's great. I'm going to hand it off to Brandon. Panelists, thank you very much. Speakers, an extra thanks for putting all that together. But again, a lively discussion, a good one, with good representation and some great ideas come through. So thank you, Brandon.
Yeah, thanks. Just adding my appreciation. This is the second one of these that we've done. You know, there's really no, motivation other than to just discuss this in a kind of an open way, bring people from multiple, stakeholders, and have kind of the kind of open and honest, transparent, hopefully constructive, focused on what can we do collectively on these kind of challenging issues. So I think this has been really helpful. This is the second in a series of 3. The third intended to look at the extensive work that's gone on with vessel noise. That'll happen sometime probably in the spring of 2023. And then there'll be some sort of synthesis of the 3 of these that have happened that is still sort of taking shape. But yeah, thanks so much. I dropped a plug in, a shameless plug for the DOSITS webinar, which Juliet thankfully forwarded to everyone. I couldn't get just the panelists to show up. So that's on Wednesday, the 20th anniversary webinar for DOSITS is up there. So you have to register, but there's a discussion on Wednesday on kind of the future of research on different and noise impacts on different taxa. So check that out. And I think with that, we will go ahead and close. Just thanks again to the speakers, to the panelists. And you should get some information following the workshop on synthesis of some of the questions and responses. And we'll have a report that we'll send everybody that registered for the webinar. And yeah, keep an eye out for the announcements for the one on shipping. Doug or Juliet, anything else to add?
Nope. Thanks for the discussion.
All good.
Yep.
Thank you.
Thanks all.